All right, so I wanted to just do a quick review of L'Hopital with you, since I managed to leave those off of our exam review. So a couple of quick things. Let's write down just some basic forms / clues that we should look for. So the first form is when you see infinity over infinity or 0 over 0, those are when we can apply L'Hopital's rule. So you should just use L'Hopital. You do need to think about in the 0 over 0 case, technically speaking, we need to make sure that the bottom function, its derivative is not 0 or going to 0. But those are details that I probably will not test you over tomorrow. So that's the forms that we're looking for to be able to use L'Hopital. If you get a form like infinity times 0 plus or minus infinity, whatever, then this is a clue, a form where you should try to pull something downstairs. And we'll do an example of this in just a minute. If you happen to see an infinity minus infinity, we saw some of those in class and also on the homework, you might consider looking for a common denominator. And if you can find one, you might be able then to get into a form of either infinity over infinity or 0 over 0. The fourth one that I want to mention, the fourth kind of clue, is if your function is f of x, looks like f of x equals a variable somehow raised to a variable. There might be, plugged into a function, who knows. But if there's variables somewhere here and variables somewhere here, this is when you should consider looking at the limit of x as x goes to whatever of the natural log of f of x. Take the natural log of your function, consider there, and then you recover the original limit by setting your answer to this part as the exponent on e, which we talked about. Okay, so that's the quick review. Those are the forms. Those are the clues that I'm looking for. Here's the 4 examples that I gave you guys as practice. So number 1, we said let's study the limit as x goes to infinity of what? The sinh of x over x to the 4th. This is what I would consider to be a relatively basic L'Hopital. The form here is infinity over infinity. And so I just take derivatives. I say this is, I'm going to come down a line here. This is equal by L'Hopital to the limit as x goes to infinity of the cosh of x over 4x cubed. Still infinity over infinity. Do it again. I get the limit as x goes to infinity of the sinh of x over 12x squared. Suddenly you kind of get the pattern. I'm going to do this 2 more times, and the variables downstairs are going to go away. For completeness sake, I'm going to write it all out here. I probably wouldn't put a 4-step problem on a test just for time's sake, but you should be able to do it. I get what? Cosh of x over 24x. Form is still infinity over infinity. So last time I get the limit as x goes to infinity of the sinh of x over 24. And now what's happening, sinh, if you think about the graph of sinh, right, rough graph here, it's blowing up to infinity. So this is just infinity. The answer is infinity. You probably could have guessed that all along. Sinh is built from exponentials. Exponentials dominate polynomials. And so somehow I expected this thing to win. So that's number 1, repeated L'Hopitals. Notice I wrote LH every step. You can do an L, that's fine as well. Notice I wrote down the limit every single step. I expect that from you on your exam. Okay, number 2. Let's look at, what do we have? The limit as x goes to 1 of x cubed minus 1 over x to the 4th minus 1. Here, the form is, if we plug in 1, we get 0 over 0. And so this is another indicator that we should do L'Hopital's rule. We have the limit as x goes to 1 of 3x squared over 4x cubed. Now, if you think about forms, you just plug in and you get 3/4. So this one, there's not a lot to this one. This one is pretty clean. if this was going to 0, you might get a mess over a mess. The point is, in general, you should simplify before doing L'Hopital's again. You don't need to do L'Hopital's rule again here, but you should simplify in general. So before I sort of write this out and conclude this thing, I'm going to write one more step just as a matter of habit. I'm going to say this is 3 over 4x, which then is 3/4. And yeah, you could have jumped right here, but the point is you should simplify before doing L'Hopital's again. So this one worked out nice. Okay, let's move on to the third one. We have the limit as x goes to 0 from the right of the tanh of x times the natural log of x. So thinking about the form here, tanh is going to 0. Tanh of 0 is 0. If you don't remember that, tanh is what? Sinh over cosh. Sinh of 0 is 0. If you forget those things, you actually could write down the definition of sinh and cosh and plug in 0 and work it out. But the point is, you get 0 times minus infinity. The natural log of x, as x goes to 0 from the right, natural log of x is going to minus infinity. So this is a clue that we should try pulling something down. I don't have any tricks for you. To me, though, when I see a trig function, not trig function, hyperbolic function, or a trig function like tanh or tangent, it's easy to pull those downstairs. You flip them. And so I'm going to try saying this is the same thing as the limit as x goes to 0 from the right of the natural log of x over the cotanh of x. See, that's the nice thing about pulling tanh downstairs. It just comes down as cotanh. Now my form is minus infinity over infinity. And so this thing is blowing up, and so we're good to go here. And so we can say, okay, so by L'Hopital's rule, this is the limit as x goes to 0 from the right of 1 over x over negative cosec squared of x. We're kind of standing on an infinite pit of badness here. If you just keep doing L'Hopital's rule again and again and again, this is going to blow up on you. But we're going to simplify. So we're going to realize that I've got a cosec downstairs. That comes back upstairs as a sinh, right? Cosec is 1 over sinh. So I can pull that upstairs as a sinh, and I can write this as the limit as x goes to 0 from the right of negative sinh squared x over x. I actually need to do L'Hopital again because now the form here is 0 over 0. But I can handle L'Hopital one more time, and I get the limit as x goes to 0 from the right of what? Negative 2 sinh x cosh x all over 1. This limit you can evaluate directly. Sinh of 0 is 0, cosh of 0 is 1. And so the point is this is just 0. And I just had to pull some things downstairs to make it happen. So that's number 3. Number 4, the last one on this quick review, I wanted us to look at the limit as x goes to infinity of x to the 1 over x. I feel like we may have seen this one as a homework problem. I don't remember, but we'll do it again here. The point is I see variables in the base and in the exponent, so I'm going to say consider the limit as x goes to infinity, natural log of this whole thing, pull the 1 over x down. So I'm going to get, let me rewrite that. I'm going to get 1 over x times natural log of x is where I end up. Let me erase this. There we go. That's where I get by taking the natural log of this guy, pull that down. I'm here. And so I'm going to clean this up and write this as the limit as x goes to infinity, ln of x over x. The form here is infinity over infinity, so this is a relatively straightforward L'Hopital's rule. You end up with what? 1 over x over 1. This limit is just 0. So the original limit is what? E to the 0, which is 1. All right. Good luck on your test tomorrow. That's it for today.